I was given feedback that my previous video at about this point started to have some weird audio. And it's just taken me a little bit to have some time to remake the video. So this is going to be a brief discussion of the enteric nervous system and the wall of the GI tract. And it goes along with the video from the first video for digestion that I posted previously. So this is the image from your textbook showing the parts of the digestive tract. I went through this in the last video, so I'm not going to spend extra time on this now. But what I did not get to talk about, or I did talk about, but it sounded really weird in the last video, is that the GI tract, of course, you guys should know, has 4 layers to the wall, right? We've got the inner mucosa layer, then we've got the submucosa layer, the muscularis externa layer, or the muscularis layer, which includes the circular layer and the longitudinal layer in most GI tract organs. In the stomach, there's an additional muscle layer called the oblique layer. And then we have the outer serosa layer. In the walls of the GI tract, you'll see that there's a lot of nerve innervation. In fact, the GI tract, the gastrointestinal tract, is said to have its own brain. And I say brain, and I'm putting air quotes, and I don't have the webcam up because I literally woke up and came downstairs and did not brush my hair or anything at this point in time because I'm launching my AP1 exam today. So sorry, there's no picture of me right now. You don't want to see me. I need to shower. Okay. So anyways, I'm putting air quotes around the brain, right? So the brain has this, what we're referring to is really these plexus structures. A plexus is a branching of nerves. And so we have these plexus structures that surround these different parts of the GI tract wall. And this picture over here on the right shows the stomach and the small intestine kind of stretched out a little bit here. But what you're seeing is in yellow, those are nerves there. And so everything that looks kind of greenish or yellow shows you how innervated the GI tract wall really is. And so what the enteric nervous system does is it regulates how the muscles contract in the wall of the GI tract, and it also will stimulate gland secretion. And you see these glands here in the submucosa. These glands, depending on what part of the GI tract we're talking about, can secrete many different chemicals, enzymes, hormones sometimes. In the case of the stomach, it might be the hydrochloric acid, right? So the glands are secreting different materials. There's also glands in the mucosa region as well. Here's another image of the GI tract wall. This is from your textbook. You're seeing the mucosa, submucosa, muscularis, serosa. And you see, again, these different nerves innervating the submucosa, and the myenteric plexus is innervating the muscle layer. So what is really interesting about this is that this brain, air quotes, right, of the GI tract can make decisions and stimulate, gland secretion or muscle movement without stimulation from the central nervous system. So that's what I'm going to talk about in the next slide here. We say that the enteric nervous system, the one that controls the GI tract wall, participates in both what we call short and long reflex arcs. So short reflexes are mediated completely entirely by the enteric nervous system without communicating to the brain, or with later communication to the brain. So for instance, it says here, there are stretch of walls, like food coming into the GI tract and the walls stretch, or chemicals that are present in the food can stimulate the GI tract to release chemicals or start moving materials through, or churning or mixing materials without getting told to do that by the brain. Okay. The long reflexes would involve some central nervous system stimulation or communication. Okay, so remember CNS integration centers, we're talking about the brain and the spinal cord. And typically what the brain and the spinal cord, particularly the brain, is telling the gut to do is really kind of an interesting process. It sort of happens before food even gets into the gut, or sometimes right when food gets into the stomach. Okay, so it says long reflexes can be initiated by stimuli arising inside or outside of the GI tract. Here's examples of outside the GI tract stimuli so that it makes sense to you. If you look at food, if you think about food, if you smell food, right, before it even comes into your mouth, your head or your brain is interpreting that information and then will tell your GI tract to prepare for the food entry into your GI tract. Here's an image to see kind of what I'm talking about just visually here. So if we have the GI tract, alimentary canal, same thing as the GI tract, gastrointestinal tract, okay? GI right here, okay? So what this is saying, okay, food's in the lumen of the alimentary canal. The short reflexes are going to work by the enteric nervous system. So internal GI tract stimuli like food being present in the stomach, in the small intestine, stretching the walls, that would be mechanoreceptors. The chemicals that are detected, like if food's really acidic, right? It's probably in the stomach. Those kinds of things can send information to the local intrinsic nerve plexus, which we said is the gut brain. So these would be, these chemoreceptors, osmoreceptors, mechanoreceptors would be in the wall of the GI tract organs and sending information to the gut brain right there. Okay? The gut brain, that nerve plexus that's in the wall of the GI tract, can send information via to the smooth muscles or glands, and then it would change the contractile secretory activity right there. Those chemoreceptors, mechanoreceptors, and osmoreceptors can communicate to the central nervous system, and if that happens, then we say that's a long reflex. And the central nervous system can send stimulation via autonomic efferents back to the gut brain to enhance the action of the smooth muscle or the glands. Additionally, here's an external stimulus, right? Or several different external stimuli. If you see, smell, taste, think of food, then the central nervous can stimulate the gut brain to then start moving the walls of the GI tract to move, get, prepared for motility. And really, very importantly, to stimulate the glands to start secreting materials to prep for food entry into the GI tract.